Hello students, today's topic is continuous probability distribution. As we have seen in the beginning of the module, the random variables are classified into two types, discrete and continuous random variables. When x is a continuous random variable, the values of x are in the form of intervals like a closed interval a b. X may vary in the closed interval a b. That is, x may be greater than or equal to a, less than or equal to b, or x may vary in the open closed interval a b. X may be greater than a, less than or equal to b, or x may vary in the closed open interval a b, where x is greater than or equal to a, less than b, or x may vary in the open interval a b, or x may be greater than minus infinity and less than plus infinity. A function f of x of a continuous random variable x, a function of a continuous random variable x denoted by f of x, satisfying the condition that f of x is greater than or equal to 0 for all x, f of x is non-negative for all x, and integral of f of x with respect to x from minus infinity to plus infinity is equal to 1. A function of a continuous random variable x denoted as f of x satisfying these two conditions is called as a continuous probability function or probability density function, PDF, probability density function. When x is a continuous random variable, to find the probability that x varies in an interval, the probability or the chance that x varies in the closed interval AB, the probability that x will be greater than or equal to a, less than or equal to b, or the probability that x will be greater than a, less than or equal to b, or the probability that x will be greater than or equal to a, less than b, or the probability that x is greater than a and less than b, all these probabilities are equal. When x is a continuous random variable, the probability that x varies in the interval a to b is given by integral of f of x dx from a to b. Lower limit of the integral is the left end of the interval, upper limit of the integral is the right end of the interval. Similarly, the probability that x is less than b or less than or equal to b, including b or excluding b. Here the left end is not shown, so understood x is greater than minus infinity. The probability that x is less than or equal to b is nothing but integral of f of x with respect to x from minus infinity to b, where f of x is the probability density function of the continuous random variable x. Similarly, the probability that x is greater than a or greater than or equal to a, here the right end of the interval is not shown. So understood, x is less than plus infinity. Probability that x is greater than or equal to a is integral from a to infinity. F of x dx, where f of x is the probability density function of that continuous random variable. This y naught into e power minus mod x should be non-negative. E power minus mod x exponential factor which is always non-negative. So y naught into e power minus mod x, one factor is always non-negative. So if this product is to be non-negative, then the first factor y naught also should be non-negative. So y naught should be greater than or equal to 0 using first condition. Second condition is integral of f of x with respect to x from minus infinity to plus infinity must be equal to 1. Here from minus infinity to plus infinity, x from minus infinity to plus infinity, in the question f of x is given as y naught into e power minus mod x. So straight away you can substitute f of x as y naught into e power minus mod x. Since that y naught is constant, we can keep it outside the integral sign. So y naught into integral e power y naught into integral minus infinity to plus infinity e power minus mod x dx must be equal to 1. Now see this integral. See the property of a definite integral of the form minus a to plus a f of x dx. When you have an integral of this type, minus a to plus a f of x dx, then if f of x is even, integral will be 2 times integral 0 to e f of x dx. Here the integrand f of x is e power minus mod x. F of x is even. To test whether f of x is even, replace x by minus x. F of minus x will be e power minus mod of minus x. And mod of minus x is same as mod x. So e power minus mod of minus x will be e power minus mod x. Same as f of x. So this condition f of minus x is equal to f of x is satisfied in case of this f of x, the integrand of the integral. So since this integrand is an even function, integral from minus infinity to plus infinity, f of x dx can be written as integral 2 times integral from 0 to the upper limit infinity, f of x dx. So that is what we have done, 2 times. So left side becomes 2y naught integral 0 to infinity e power minus mod x dx equal to 1. Now integral 0 to infinity means all x values are non-negative. When x is non-negative, mod x will be equal to x itself. So it will be 2y naught into integral 0 to infinity e power minus x dx must be equal to 1. And integration of e power minus x is minus e power minus x. Take the difference at the upper limit infinity, lower limit 0. Right side is 1. 2y naught into, putting x as infinity means as x approaches infinity, this approaches e power minus infinity, e power 0. So at the upper limit this will be 0. Minus. At the lower limit, e power minus 0, minus of e power 0, minus of 1. So 0 minus of minus 1, 0 plus 1 is 1, bracket is 1, 2y naught into 1 is 2y naught. So we get 2y naught as equal to 1 or y naught is equal to 1 by 2. Then mean mu. Integral from minus infinity to plus infinity x into f of x dx. Here for x from minus infinity to plus infinity, f of x is already given in the question, y naught into e power minus mod x. Y naught is a constant, can be kept outside the integral sign. So integral minus infinity to plus infinity x into e power minus mod x dx. And again an integral of the form integral minus a to plus e, lower and upper limit are same with opposite sign. Integral from minus a to plus a f of x dx. That will be 0 if the integrand f of x is odd. 2 times integral 0 to a f of x dx if the integrand f of x is even. So here the integrand f of x. Put x as minus x, it will be minus x into e power minus mod of minus x. Mod of minus x is same as mod x. So minus x into e power minus mod x minus x into e power minus mod x means f of x itself. So we get f of minus x as minus f of x. So this integrand is odd. So integral will be equal to 0. Y naught is a half, that integral where the integrand is odd will be 0. Half into 0 or equal to 0. Next question. Find the constant k such that the function f of x is a probability density function. So suppose this function f of x is probability density function of a continuous random variable x, then what must be the value of this k? When you say that this f of x is a probability density function, this f of x will satisfy that two conditions. One is f of x will be greater than or equal to 0 for all x. Another one is integral from minus infinity to plus infinity f of x dx will be equal to 1. So to find k, you can make use of the two conditions. Then compute probability that x will be greater than 1 less than 2. Probability that x varies in the interval 1 to 2. Probability that x will be less than or equal to 1, and probability that x is greater than 1. Students, remember that it is the question from the model question paper of 2020. Now to find k, since f of x is a probability density function, integral of f of x with respect to x from minus infinity to plus infinity must be equal to 1. Now you have to substitute for f of x. Question says f of x is kx square for x between 0 and 3 and 0 for all other x values. So here it is minus infinity to plus infinity. So straight away we can't replace f of x by kx square or 0. So you need to split this integral from minus infinity to plus infinity as minus infinity to 0. Then integral 0 to 3. Then integral 3 to infinity. So that for integral from 0 to 3, there in place of f of x you can write kx square. In all other integrals where x is from minus infinity to 0 and x is from 3 to infinity, f of x can be replaced as zeros. Only for 0 to 3, f of x can be replaced by kx square. So first integral and third integral will be zeros. Only the second integral remaining in the left side. Integral 0 to 3 kx square dx, where k can be kept outside the integral sign. Integral 0 to 3 x square dx, right hand side will be equal to 1. K into integration of x square is x cube by 3. Take the difference at the upper and lower limit at 3 and 0. Right side is 1. K into putting x as the upper limit 3. 3 cube is 27 by 3 means 9, minus putting x as 0. 0 by 3 will be 0. Right side is 1. So 9k will be 1, or k is 1 by 9. Next is the probability that x varies in the interval 1 to 2. Probability that x varies in the interval a to b. Integral a to b f of x dx. Here integral 1 to 2 f of x dx. Now 1 to 2, and that 1 to 2 comes between 0 and 3. So in place of f of x, straight away you can replace kx square by keeping k outside the integral sign. K into integral 1 to 2 x square dx. And integral x square is x cube by 3. Difference at the upper limit 2, lower limit 1. K is 1 by 9. So 1 by 9 into, put x as 2. 2 cube is 8. 8 by 3 minus, put x as 1. 1 by 3. 8 by 3 minus 1 by 3 is 7 by 3. 1 by 9 into 7 by 3. 7 by 27. Probability that x will be less than or equal to 1. Upper limit is 1, lower limit will be minus infinity. So integral from minus infinity to 1 f of x dx. F of x will be kx square from 0 to 3. So this is minus infinity to 1. So split the integral from minus infinity to 0, 0 to 1. Minus infinity to 0, 0 to 1. In that integral from 0 to 1, in place of f of x, write kx square. For otherwise f of x is 0. So first integral will be 0. In the second integral, k can be kept outside the integral sign. Integration of x square with respect to x is x cube by 3. K is 1 by 9. In place of integral x square with respect to x cube by 3. Differentiate the upper limit and lower limit. Put x as 1, put x as 0. 1 by 9 into 1 by 3 minus 0 or 1 by 27. Probability that x is greater than 1. Probability of an event A is same as 1 minus probability of the event A bar, complement of E. So probability of x greater than 1 is same as 1 minus probability of complement of x greater than 1. Complement of x greater than 1 means x not greater than 1, means x less than or equal to 1. So probability that x is greater than 1 will be same as 1 minus probability that x is not greater than 1, probability that x is less than or equal to 1 minus. So why we write this probability in this form, not in the integral? Because probability of x less than or equal to 1 is straight away calculated in the previous part. If we had not calculated this, we could have straight away gone for integral. Since this is already one part of the question and already calculated, we can make use of that to find the last part. We need not go for the integral. So 1 minus this probability is 1 by 27. So which will give 27 minus 1, 26 by 27. Answer for that second question.